Namaste, students. We should be open to page 376 in our green math books, and we're looking at chapter 8, lesson 4 today. This one is all about volumes of rectangular prisms. And our learning target will say, I can find the volume of a prism using a formula. Let's get that in first. I can find the volume of a prism using a formula. So one thing that's different in today's lesson is we're dealing with volume, which is a different measurement that we've been dealing with earlier this chapter. So at the top of page 376, you'll see the key idea about volume. The volume of a rectangular prism is the product of the area of the base and the height of the prism. So let's go ahead and write down the word volume, since this is a new one for us so far this year. When we're trying to find the volume of something, we're talking about how much space is inside. So that's what we'll write first. How much space is inside? And since we're talking about the inside of a box or some sort of shape, this has to be a three-dimensional figure. So we're trying to fill something, for example. And then it just gave us the formula there for a rectangular prism. So we'll do volume of a rectangular prism. So what we're going to do is put V equals, that stands for volume, is, we're going to take the area of the base, multiply it by the height. So I'm going to put a little arrow there that says area of the base, and then the H stands for height. Another way of thinking about this formula would be length times width times height. It's the same formula. Length times width would be the area of our base, that's the B, and then we multiply by the height. So that's just two different ways of writing the same little formula. And remember, rectangular prisms look like a little shoebox or some kind of rectangular box. So I'm going to make a little picture here. So we have an example of what we're going to be looking at today. So that's kind of what we're going to be looking at. So looking at those, we're going to start into example 1. And what we see in example 1, which a lot of you are going to be sad about, is fractions. So fractions just don't go away, remember. We have fractional side lengths, this one. So example 1 is all about finding the volume of the prisms. So we're just going to put find volume. So example 1a, they give us a rectangular prism. So we're going to try to draw what we see the best we can. So remember, we're going to kind of have our slanted sides out, trying to draw to the best of our abilities this rectangular prism. Pause the video if you need to watch that again on how I just created that. Let's put the measurements on. This distance here, this is going to be called our length. They tell us that's 7/8 of a meter. Then this distance here, we're going to call that our width. They give us 1/2 of a meter here. And then this distance here, we're going to call that our height. They give us 5/8 of a meter there. So if I'm using our formula up here, I'm going to take length times width times height. So our volume is going to equal length, which is 7/8, times width, which is 1/2, times height, which is 5/8. If I multiply all those sides together, I'm going to get our volume. Now, something that's nice about multiplying fractions that we learned earlier on in a different chapter is that you just multiply the tops and multiply the bottoms. Now, before we do that, we can take a look and see, is there anything on the top that we can cancel on the bottom? And 5 and 8, 5 and 2 doesn't have any common factors. 7 and 8, 7 and 2 also don't have any common factors. So there's really no canceling happening or simplifying. So we're just going to go 7 times 1, which is 7, and then multiply that by 5, and that would end up with 35 on the top. And the bottom, 8 times 2 on the bottom, that's going to give us 16. And then 16 times 8, that's going to give us 128 on the bottom. Now, since I couldn't cancel or simplify on this stage, I know that 35 over 128 is my final answer. We just have to make sure we add a label. So our label on this one is meters, so we have to put in meters. Now, when we're labeling volume up here, instead of putting a little 2 above it, we're going to put a little 3. We're dealing with 3-dimensional shapes. So I'm going to go back up here, change back to blue, and add that to our vocabulary notes because there is a different and special label that we have to put. So I'm going to put a little label over here. Volume label is units, whatever units you're talking about, and a 3. That's very important to remember. Just like area, if you do not label correctly, I would mark it wrong on a test. So now we'll go back to this example. And we finished example A. We'll go ahead and look at example B. This is another box. Again, we have fractional side lengths. So we'll go ahead and try to draw it as best we can. And again, if you are trying to draw this and I'm going a little too fast for you, just pause the video and watch again. So in this one, all the side lengths are the same. So really we have a cube here, but a cube is a type of rectangular prism. So we're going to solve this the same way. They tell us that this is 3/2 of an inch. This side here is also 3/2 of an inch, and the height is also 3/2 of an inch. So we're going to solve it the same way. Volume equals length times width times height. So 3/2 times 3/2 times 3/2. The 3's and the 2's can't simplify, so we're just going to multiply straight across. 3 times 3 gives us 9, and 9 times 3 gives us 27. On the bottom, we have 2 times 2, which gives us 4, and 4 times 2, which gives us 8. Now, looking at this improper fraction, we can take it one step further because we can take this and make it a mixed number. So how many 8's can go into 27? Well, 3 8's would get us to 24. So we can make a big 3, and then what the leftovers are will go as the fraction. There are 3 leftovers from 24 to 27 over 8. Putting our label on, we have inches this time. And then we have to put our little 3 since this is a volume we're trying to find. So there are my 2 final answers for these first 2 rectangular prisms and finding their volume. Go ahead and pause the video and try the 2 at the bottom of the page 376 to get some extra practice. All right, if you tried those out, number 1 should have been 2/3 feet cubed, and number 2 is 27 over 64 yards cubed. And we say cubed when we're talking about the little 3, or to the 3rd power. Okay, looking at the top of page 377, we'll get to example number 2, which is using the volume of a rectangular prism. And in order to use the volume, it's kind of giving us a real life situation here. It says 1 cubic foot of dirt weighs about 70 pounds. How many pounds of dirt can the dump truck haul when it is full? And in the book, you'll see a picture of a dump truck, and the bed of the dump truck has labels on it. It gives us the length, the width, and the height of the dump truck bed. And we're going to be able to use that to figure out what the weight of all of this dirt is going to be. So let's talk a little bit about what they give us. The first thing they give us is that 1 foot cubed of dirt is going to weigh 70 pounds. So that's important information we need. And then they give us a picture of the dump truck bed. So if we want to draw a picture of that, let's do a little rectangular prism here. Let's pretend that this is the back of the truck. And let's put the measurements on it. So you don't have to actually draw the truck. We just need the back of the truck. So let's say this is the back of the truck. Here's some wheels if you wanted to put on some wheels. And let's put on our measurements now. They tell us that the length of the bed of the truck is 17 feet. They tell us that the width of the bed of the truck is 8 feet. And then the height of the bed of the truck is 4 3/4 of a foot. Now over here, we'll write what is the question they're asking us to find. So they're asking us for how many pounds, or the weight, of dirt can the dump truck haul? And of course, that's asking if it were full. So the first thing we need to do is ask ourselves, how much can it hold? That's the volume. So the volume will be length. Oops, that's a 2. We wanted a 7. Length times width times height. Now, if you look, we've got a whole number, and then a mixed number. So to make this a little bit more simple, we can write it like this. 17 over 1 times 8 over 1 times, now let's change this into an improper fraction. 4 times 4 plus the 3. So we've had 16, 17, 18, 19 fourths here. All right, well, let's take a look here. Can we do any canceling? Well, we can. This 4 can cancel and make it 1, and this 8 would make it 2, because 4 can go into 4 once, 4 can go into 8 twice. So now we have all 1s on the bottom. So 1 times 1 times 1 is 1. We have 17 times 2, and we take that and multiply it by 19. Doing that gives us 646. So if we were trying to find our volume first, so volume is 646, and we have feet cubed. That's our volume. Now go back to our question. It says, how many pounds can the dump truck haul? Well, if each 1 foot cubed is 70 pounds, we have to take 646 and multiply it by 70 pounds. So 646 for our volume, multiplied by 70 pounds per cubic foot, is going to end up giving us a nice big number, 45,220 pounds. And that's how many pounds this big dump truck can haul of dirt. We've got one more example, another one in a real life context. So example 3, we'll switch colors here. And this one says finding a missing dimension of a rectangular prism. So I'm going to put find missing dimension. And a dimension is basically like a side length. So if you see that on a test or on an assignment, dimension, it's just your length, your width, or your height. It says write and solve an equation to find the height of the computer tower. So the first thing you might want to do is draw the little computer tower. Computer tower is a rectangular prism. My computer tower in my room is a little different looking than this, but some computer towers are like tall boxes like this one. In the picture, it has an H for the height, so we're not sure what the height is. It has a 7 inches for its length, and then its width is 16 inches. So that's our computer tower and what it's given. They also tell us that the volume is 1,792 inches cubed. So they already give us the volume. So this particular question is asking us to find the height. So first thing we're going to do is write an equation that we could use to find this. So our equation, instead of having V equals, we actually know the volume. So we're going to put the 1,792 in the front and our equal sign. So up here, instead of V equals, we actually know the volume, so we're going to put that number equals. Now remember, to find this, we have to go length times width times height. So our length is 7 times our width, which is 16, times our height. And in this case, we don't know our height, so we have to put an h. So this is our equation that we would use to find the volume. Now we want to solve the equation and figure out what is this height. So if I look over here, I see 7 times 16. I can actually put those together by multiplying. So that'll going to be our first step. So we didn't change this first number, but we are going to change these two numbers because we're going to multiply those two together. When I do 7 times 16, I get 112. So I have 112 times height equals 1792. So now I'm going to go back to chapter 7 where we draw a line down the middle and we're going to solve. Remember that if you see multiplication like this, to get rid of it, we are going to divide. So if we divide 112 by 112, we have to do the same thing over here. That cancels these out, and now I have height equals 1,792 divided by 112, and that actually gives us 16. So the height of this computer tower is 16 inches. I'm not going to put the little cubed on this one because we're not trying to find volume. We're just trying to find one of the side lengths, which is the height. So 16 inches would be our height of the computer tower. Pause the video again and try the last three on your own on page 377. Okay, if you tried those out, number 3 would be 53,200 pounds. Number 4, writing and solving an equation for that, it would be 72 equals length times 6 times 2. And then our length would be 6 inches. Number 5, our equation would be 1,375 equals 20 times width times 5.5. And then if we solve for the width, it would be 12.5 centimeters. And that's the end of chapter 8.